Oh, this we did, right? Okay, dear, we can go for another one.
Recording in progress.
Okay, right now. Okay, that was typical. Okay, iron oxide reacts with dilute sulfuric acid to make iron sulfate. Construct the equation for this reaction. Now, there's no doubt we don't have to write the ionic equation for this. They're asking for equation, just the normal equation. So iron oxide is there, even the oxidation number is there. Very good. It's easy for you, right? Iron oxide reacts with dilute sulfuric acid. Now that you should know how to write a symbol for the sulfuric acid, right? To make iron sulfate, right? That's all they have given. Okay. So in that case, you have to just write the reaction. Oh, just write the equation for the reaction, right? Iron oxide is what? You can write iron 2 oxide is like this, right? How does it come? That's from crisscross. That's how you learn the crisscross as basics, right? Yeah, at the beginning you learn crisscross for this, right? Iron oxide plus dilute sulfuric acid. You should know how to write sulfuric acid ion. Sulfate ion is there now. It's 2SO4, right? So this one is H2SO4. And then you get what? Iron 3 sulfate. They have given iron 3 sulfate like this. Yes, they have even given the formula. That's very good, right? Pretty easy. The most difficult one they have already given. Okay. So now iron sulfate is there and you just have to balance it. You have to balance it. If you write an equation, you have to balance it, right? Okay. If you write it, you balance it. Not about the sulfate. You can put sulfate. You can think sulfate as a group, isn't it? In some cases, like in some of the things, we can do that, right? You know, if there's no other sulfur here on the other side, that means it is not broken down separately, like any other place that you find sulfur again, right? If not, you can see the sulfate group as one whole group. So it's a polyatomic ion, or you can say a compound ion now. So now see this compound ion sulfate, if they are here too, right? There are 3 sulfate ions in this sulfate group. Just because of this iron sulfate, the ion number change, right? You get sulfate 3 sulfate ions. 3 sulfate ions. So make this sulfate ion a 3 by multiplying by 3, right? Right? So then now what happens? Think your equation is balanced. Now you get hydrogen 6. Oh, what happens to the other part? Yeah, that's what they have not given the rest. What is the other thing that you get? You need to put the other substance they have not mentioned for you to write it. Where is that? You need to write it like it's hydrogen. It's hydrogen or water? It's going to be water, right? Here it is acid and base. Yeah, sorry. Yeah, it's for acid and water. Sorry, acid and not so acid and water. Acid and base reactions, so salt and water. Yeah, so this is water. And now you can see whether you're balancing this sulfate. I did make already. Now let's see the rest of that. We have 3 hydrogen, sorry, 3 times 2, 6 hydrogen atoms. Here, 2 hydrogen atoms. That means you have to multiply that also, same way, by 3, right? Isn't it? You put 3 there, then you get 3 hydrogen. Now 3 into 2, 6 again. And this oxygen also now balanced, 3 times oxygen. And see here, there's 3 oxygen. That will be balanced with that, right? You don't need to interfere with this sulfate group. Because here there's sulfate group, these 3 sulfate groups are balanced with this one. You don't have to check back again, right? This is sulfate. Now sulfate is balanced with this one. That's over. That oxygen you don't have to count again. But this oxygen, these 3 oxygen separately are there here in the water molecule, right? And there's 2 iron ions, 2 iron atoms, right? Okay, so that's balanced, huh? Understand? But there's, because it's 1 mark, they won't consider the state symbols. They don't want the symbol, but they need the balance equations to them. Always. They don't even mention balance. You have to balance it. Okay? And whether now maybe in many questions you saw that they don't ask you to write the balance equations, but they expect that balance equation to give that 1 mark. It won't be otherwise awarded to you in vain. Right? If you want to save marks, even this matters, right? Is it that question? Yeah, we did it right now, right? Okay, another one. Explain how the equation shows that the reaction involves oxidation. Now for this kind of things, again that explanation question, right? See, you are supposed to write this time why this reaction involves oxidation. You need to say that this equation, why does it show oxidation? Iron 2 plus iron sulfate is there, and it becomes iron oxide and sulfur dioxide and sulfur trioxide. Here they have given a statement also iron sulfate, iron 2 sulfate, thermally decomposes to form iron 3 oxide, sulfur dioxide, and sulfur trioxide. What has happened to iron actually? First of all, you can see whether what has happened to this iron atoms. You can see it in the sentence even, Trigger. Look at this. Even in the statement, you can find it. It's oxidation, isn't it? Right? Iron 2 plus becomes 3 plus. That's oxidation. Or else you can see here, you can break this down into 2 ions and find out yourself. This is sulfate ion. Sulfate ion is famous 2 minus ion, right? The 2 minus ion on this side, so this one should have been 2 plus. This balance number doesn't affect the oxidation numbers. You know that, right? The balance number is there to balance the atoms. Here in this case, oxygen and ions on, you know this 2 came from this oxygen and 3 came from iron. So 3 plus here, right? If you break this down, you get what? Sorry. If you break down, you're getting 1 iron atom containing what? 3 plus and oxygen atom containing 2 minus. Here iron 2 plus and this becomes a sulfate minus 2, 2 minus 1, right? Oh, that's like my one. Okay, right. So what happens? What has oxidized? Iron 2 plus, right? You don't need to check anything. You can say iron 2 plus. Again, you can try the same story of iron 2 plus iron. No, we wrote a reduction previous, right? This is actually oxidation. See, iron 2 plus iron has lost 2 electrons, or 1 electron, right? Lost 1 electron. We write 1 with this 1 E. Write the symbol like this. This E, you have to put a minus sign, right? To form iron 3 plus ions. You need to write this stuff. Carelessness count a lot in this subject, right? If you are careless if you can't be bothered to write these words chosen carefully, you're not a science person. Be carefully writing them, right? So write all the words if you want to get marks. Otherwise, you're getting the marks that you deserve for being careless, right? Okay. So we have to write like that. Okay. Next one is this one. Okay, fermentation of glucose produces carbon dioxide. These kind of statements are there sometimes, and they ask you to give the equation for the fermentation of glucose. What does that mean? Glucose, you should know glucose, C6H12O6, right? Okay. Now you should know how to write carbon dioxide also, CO2. And don't write nonsense here, right? Okay. And you know what else is produced, right? You have to write the fermentation one Fermentation reaction means you get ethanol as well, right? The other product is ethanol. So we need to write this C6H12 O6 becomes carbon dioxide and ethanol. Ethanol you need to write then in that case C2H5OH, right? Because it's an alcohol formula, you know, alcohol formulas, general formula, you can go to the general formula and write it, or else you can say what in this question, I think there was a part of that. Maybe the alcohol's formula was already there. Even if you don't have it, you can use the general formula of alcohol, and it's an ethanol. So ethanol means second carbon, right? The two carbon atoms, you can make it for that, right? Okay. What's the general formula for alcohol? CnH2n plus 1 OH, right? Here you go. So that's carbon 2. So carbon 2 means 2 times carbon, sorry, hydrogen means like hydrogen has to be 2 times that plus 1. So like this 2 times 2 is 4, 4 plus 1, 4 plus 1 is 5. Okay, and OH. That's ethanol's formula in case you have the problems, right? Right, that's it. And you have balance this. Is it balanced? Not balanced, right? You have to balance this. Oh, they have given that to balance also, right? That means let's balance it. How do you balance this? Just everyone, right? Okay. Let's see. You can put what? This is 12, right? And put this here. That's 2 here. Put 4 oxygen. There will be how many hydrogen? Oxygen atom will be too much, right? Yeah. So you need to put here. Right? We need to increase the hydrogen number to. There's 2 hydrogen, here only 6 hydrogen. So you can put 2 in front of this and see, right? Yes. Now you get what? Hydrogen number is sorted now 2 times 5 and 1, that is 6 now, right? 6 hydrogen atoms with the 2, that's 12. That will be balanced now. Oxygen what now? There's 2 oxygen and 2 oxygen here. We need 6 oxygen and we need carbon. 2 carbon atoms, right? Yeah, we need 2 carbon atoms, right? Am I correct, children? 2 carbon atoms now. 2 into 2, 4 carbon atoms. That will be cancelled with 6, right? 2 times 2 and 2, 6. And hydrogen 12. How do you get hydrogen 12 here? 5 and 1 is 6, right? 6 times 2, 12. Yeah. Oxygen 6. 2 times 4. Yeah, 2 times 2 is 4. And then there's 2 as well. Isn't it? You balance it like just there are different ways of balancing, right? Now in this one, what I did was actually I wanted to balance hydrogen first, because I know that oxygen and carbon are there in 2 compounds. And in this compound also we have separate carbon and oxygen. So I first settled my hydrogen with this one because hydrogen is there only in 1 compound on the reactant and product side. So finished with my hydrogen, and then I sorted with my oxygen and carbon. Okay, right? Because I can't do anything else to hydrogen. You have to balance it like that. Okay, they're giving some other theoretical questions. I'm not discussing them. I'm only focusing on the equations. Right? Let's say some more ionic equations. We didn't come across that many. Aluminum is extracted by electrolysis of aluminum equation. Oh, right. I have half equation here. Aluminum oxide dissolved in molten cryolite. Write the electrode equation for the formation of aluminum atoms at the cathode. Oh, this is a half equation. So how you write half equations, children? This is the electrode of aluminum atoms, right, at the cathode. Okay, there are several ways of checking this. You can check it from the cathode's point of view. That means cathode is a negative terminal. Remember that cathode is, you can use that mnemonic there. Cathode is negative, you know that, right? The terminal is negative. Or anyway, even if there's a statement, if you go by the statement, then there's a formation of aluminium atoms at the cathode, right? That means we have to make the aluminium atoms at the cathode. Actually, you know, in the reaction, aluminium atoms are made at the cathode by what? Aluminium ions, right? We have the two ions in this substance. What are the two ions present? First of all, you should know the ions here. Aluminium is extracted. Aluminium has to be separated from aluminium oxide that dissolves in molten chloride. That doesn't involve in the reaction, you know, right? It's not involved in the formation of anything. So just break down this one. What are the compounds that we, sorry, what is aluminium oxide? Aluminium oxide means aluminium 3 plus and oxide 2 minus, right? So here we have aluminium atoms forming at the cathode. That means it should be aluminium 3 plus ions gaining how many electrons? Gaining 3 electrons because they are going to get electrons from the cathode, right? It's a positive ion. The positive ions cannot become just the simple atoms if they don't get electrons, right? So aluminium atom. Aluminium 3 plus gain 3 electrons, right? The minus sign over here. You get the 3 minus charges cancel with 3 pluses, right? To become aluminium atoms. That's it, right? And they ask for the oxygen formation as well. So that's the second ion. We have oxide here. That means we have O2 minus ion here. Right? O2 minus we can start with and write the ion for that also. O2 minus become what? At the anode. Anode is positive now. So it is going there to drop this electron, right? Now O2 minus drop the electron, drop the 2 electron and become 1 oxygen atom. Can we say 1 oxygen atom is stable? Can we write this reaction and get away with it? That's the problem with this equation, children. Technically, okay, this is what happens first. That's true. But the idea is this. We get this oxygen, 1 atom. Yeah, but then it has to go as a molecule, right? Oxygen atoms can't go out alone. It's not a noble gas, right? So if it's not a noble gas, whenever oxygen atoms are made by losing these electrons, 2 electrons by oxide ion, right? Oxide ion is losing the 2 electrons here. So we lost side on the right side, right? Lost electrons. So the problem is this oxygen atom can't go out alone. We need to write this for a molecule. Write this as a molecule. Oxygen molecule is a diatomic molecule. Diatomic molecule means there are 2 oxygen atoms. That means you should have this oxygen molecule made by taking 2 oxide ions, right? Take a different color. 2 oxide ions. And because of that, 2 oxide ions means 2 times 2, right? 2 times minus 2 means it's 4 minus charges. So here they should have lost 4 electrons. Right? Minus side out, right? 4 electrons because 2 oxide ions. This is oxide ion. Don't write oxide ion first. This is oxide ion. And 2 times that. 2 times oxide ion should be there to get oxygen molecule. Right? 2 oxide ions lose 4 electrons. Lose 4 electrons to get oxygen molecule. So usually you're not expected to write the states. Yeah, yeah, you may have to write states, right? Yeah, state and advantage of it. That's the theory part. This is the ionic half equations of this particular question. Ionic half equations, right? Half equations when you write children always write for the electrode equation. So always half equations, right? Write for what happens. They say that even though if they don't say that, you have to sometimes memorize it. But here in this case, they are mentioning many atoms like that, right? So make it for the molecule. Here they say oxygen molecules that they are not. Okay? Statement says that. Right, next one. We did that, sorry. I think it's repeated. That was we did, right? That was the one that we did. Okay. Sample of magnesium carbonate is heated strongly. That's all they say. Look at that. Now look at this type of equations. They say a sample of magnesium carbonate is heated and heated strongly. That means it's a carbonate decomposition reaction, right? So manganese carbonate. Okay, manganese carbonate or whatever the carbonate, if you heat it strongly, you might get it decomposed, right? If it decomposes, you know what are the products they can form, right? You know, calcium carbonate decomposition under iron extraction, you have learned that, right? Calcium carbonate, you know, limestone breakdown into calcium oxide and carbon dioxide, right? Remember that? So same story they're asking here. Heated strongly, breakdown of carbonates. You have it in the carbonate decomposition as well. So whatever it is, they have given the ionic number also. Focusing on this, we write the manganese carbonate. MnCO3 becomes what? It is not becoming manganese, children. It becomes manganese oxide because it cannot form anything else. And then carbon dioxide. This should be the same way as calcium carbonate. Why? Because this is also plus 2 ion, just like calcium. Calcium is also plus 2 ion, right? Here manganese also they say plus 2 ion. So there's no issue. The equation is just as it is. Same thing like calcium carbonate, right? Manganese and carbonate. The carbonate is also 2 minus ion, right? Manganese is a 2 minus, sorry, carbonate is also 2 minus ion, like this. So if you write it for manganese, right? This is a magnesium, this is manganese. Manganese 2 plus ion is common, right? The colorless ion that we talk about when it comes to potassium permanganate reduction, right? Reduction of potassium. So this one, if you crisscross, you know, they are getting, these two is getting cancelled, right? You get a manganese carbonate like this. Even if you write it oxide, yes, Mn2 plus and oxygen O2 minus, they get cancelled, no? Right. Carbon dioxide is there. And this equation is already balanced. So if you remember some of you, remember some of these things because if you're in the subject that much, you remember some stuff, right? Like it comes naturally to you. You know, calcium carbonate is when you heat calcium carbonate, that equation is already balanced equation. Right? Similarly, here also you can see manganese, carbon, carbon, three oxygen. It's already balanced. If you want, you can put the states here. It's a solid here. Metal oxides are also solids, metal carbons are also mostly solids, right? And there's gas coming out, that's G. Okay. Common mistakes are our children can write manganese. Instead of manganese, you write magnesium carbonate. Okay. Those kind of mistakes are there. Don't write those. Okay. Right. Next one again is that, oh, there's another question. They ask powdered manganese is added to aqueous zinc sulfate to form aqueous manganese sulfate. Now they ask the ionic equation from a big question. Okay. Right. Like now this type of ones we didn't come across here, right? Today. Yeah. These are the ones that you know you need to break down and write. Remember that stuff. Okay. So before that also identify the ones that are present. This is manganese. Manganese metal is there. And added to aqueous zinc sulfate. Aqueous zinc sulfate, okay, zinc sulfate. It is, zinc is a plus 2 ion always, sulfate is a minus 2 ion. So crisscross and write the formula very fast. Zinc sulfate is this one. There's no other chance of zinc sulfate becoming anything else, right? And then to form aqueous manganese sulfate. It's already given, right? So we might have another thing also, right? What is it? You should know the next thing. What will be the other product? You need to know that. Is this a reaction? What type of reaction is this? You should understand the reaction first to identify the products. What type of reaction is this? It's metal, it's a metal here, and this is a solution here, right? It's a metal salt solution, metal containing salt solution. And you can see that that metal has switched the ions here. It has switched the ions here. So this is a displacement reaction, right? These type of reactions are called displacement reactions. Remember, metal solutions. Higher metals can displace the lower metals from their solution, right? Higher metals can displace, okay, can displace the lower metals from their solutions. Right now, if this makes, if like they say that, right, if they have said, because manganese is not there in the reactive series. We don't have manganese in the reactive series. So we don't know actually of the place. If you try to find it there, you might start scolding your teachers, saying that they have not taught us manganese is placed in the reactive series. It's not the case. You don't need that to do that, right? You don't need that. You can just do it because they say here the reaction happens. If they say the reaction happens, you know manganese should be above zinc, right? Okay, so that's why you got manganese sulfate, and our other product should be zinc because this is the displacement reaction. Now the point is this: you might be able to write the overall equation, but they're asking for the ionic equation. So what shall we do? Shall we first write the overall equation and see? I'll tell you tips, right? There are several ways of doing this, but the good practice is this always. Yeah, can you switch off your video?
Sulfate will be remaining same.
Can you switch off the video? Can you switch off the video fast? You can switch off the video. Okay, yeah, right, that would be better. Okay, I was going to, I told you, I'm going to take this video and going to upload it, that's why, right? Okay, yeah, you can tell the answer, darling. What is it? Sulfate is going to be the spectral ion. Yeah, that's correct. Okay. Yeah, because
Yeah.
that's going to be sulfate is there on either side, right? You get the sulfate to be spectator, and you can see it already. Sulfate here, sulfate here. You hear the name sulfate, sulfate, but the other guys are not the same. You know that this is a compound. So zinc in this compound, the zinc state is different. Zinc is a +2 ion. This zinc and this zinc, are they the same? No, right? Zinc sulfate means it's a 2+ ion. And this zinc means the metal zinc. Okay, that's just zero element zinc. Here, manganese, powdered manganese means element manganese. Right? Oxidation state is 0 here. Right? And this manganese sulfate contains manganese's ions. So it's a +2 ion. That's why they have given that +2 ion. Right. So let's write the overall equation, children, first, and then we'll get that one, right? We write the overall equation and break it down. So some people might need that way. Okay. Manganese sulfate, and then we get the manganese and zinc sulfate. Use go to this now. Manganese sulfate and zinc, right? Okay. Now first write that, and you know you can identify the ionic numbers here. This is 0. Zero oxidation number. Zinc's oxidation number is +2 here, and sulfate's oxidation number is -2 here. Right? I'm writing this within the squares so that you can understand the numbers right separately. And then this one is also manganese here +2 here because it's already said in the question even, or else you can derive it from sulfate ion. Yes, this is sulfate 2- ion, and then this zinc is 0. Right? This is an element. If it's an element, you put the, the oxidation number is 0, right? Element's oxidation number is 0. Now what you can see is we can see the ions separately, right? We can see this ions. You can write the separate ions, or else you can just cancel the ions that are present, right? You can write ions actually better to write on the top. The charges are right on the top so that I can break down the ions itself here in the same reaction. Okay, I'm going to break it down. Here this ion, this zinc. Okay, and this is zinc 2+ ion. So I'm breaking down the ions. Zinc 2+ and sulfate 2-. Right? Here also manganese 2 plus means I'm writing manganese. And sulfate 2 minus. Okay, right, fine. Right. So if you have ions like that, now what is the ionic equation here? You see manganese is there. Now carefully choose them and write here. Manganese, the element manganese, and zinc 2 plus ions. Because our sulfate ions are getting cancelled here. Why? They are going to be present on either side. That means they are spectate ions, right? The ones who are present on either side unchanged, right? Not change. They are not changed means they are not taking part in the reaction. They are not really taking part in the reaction. So that means they are spectate ions, can cancel, or they can be omitted. We have to omit them. We need to write the ones that actually reacted, the ones that actually did something in the reaction. So ionic equation means that, right? So manganese ions and zinc 2 plus is what? You get zinc and manganese 2 plus. That's it, right? Displacement reactions, ionic equations are so easy, isn't it? Right? This is an ionic equation for displacement reaction. So that's quite like very easy. So if you can't go to this step at once, right? Please do this step. This overall equation step you can write. After writing the overall equation, break it down the ions. Break down the ions using crisscross idea, the backward crisscross, and do this. Cancel in the ions present on the either side. Then you are left with the ionic equation. Right? Ionic equation means what really happened inside the ions. And it's not magic. It is not magic. It just has some meaning here. There's a meaning. Right? Okay, I'll write here separately. Now, what happened was, here you see what happened was, manganese atoms came alone. Right? Manganese atoms came alone. And it meet with zinc 2 plus the ions. Zinc was actually already oxidized. It was an ion. But what happened was, manganese is more reactive than zinc. So manganese become ions. Zinc has to go away. Zinc has to become the element. Go away. Element alone, right? They have it has to go this place, so it has to go away alone, right? So zinc is isolating. Now this is iron earlier with this guy. Iron means it's always coming with a friend, right? It will be with a friend. Zinc, it's sulfate. Now the sulfate has gone with manganese. Manganese sulfate. That's why we say manganese ions now, right? And zinc has to go away. So sulfate ions are just present in the reaction, just not taking part in the reaction. It's just switching the sides, right? It's only switching the sides. So we write like that. Okay. Right. Let's write some more ionic equations like this. Just have to practice it. It's not difficult. Another reason of equation. That's the same thing, right? Yeah, this is also good. Now you can try this one. Iron reacts with copper sulfate to make iron sulfate and copper. Very much similar to that one. Can you try to write this? Pretty much same. Same like the previous one. Can you write? First here I didn't underline this and write the compounds, right? This is iron the metal. When you just say iron, you know it's alone. That means iron the metal, right? Fe. Then it reacts with copper sulfate. What's copper sulfate? Copper 2 sulfate means copper sulfate we write like this, right? Sulfate is a 2 minus ion and copper 2 plus is there, so they're switching up and copper sulfate is left. And then we have iron sulfate. And copper alone, Right, you found the paper. Okay. Now you're supposed to break down the ions and separate the what? I'm just writing it again. Break down the ions that are like ions that are present in the ionic compounds, right? This can't be broken down. This is already an element, right? You don't have to break down this. This is an ionic compound. We can break it down. Break down the ions. Break it down in the middle. Copper 2 plus. Right here you have copper 2 plus and sulfate 2 minus. And on the other one you have iron 2 plus and sulfate 2 minus. Copper is an element. What happens? I can write it 2 plus. So let's write it here directly. Iron plus copper 2 plus gives iron 2 plus and copper. Isn't it? Because sulfates get cancelled again. Sulfates are getting cancelled. They're the same. Copper 2 plus and iron 2 plus you have to write because it's copper 2 plus, right? This is 2 plus. I can't write it here on the top. It's an iron here. Copper 2 plus here. And iron also 2 plus here, right? Here they have given that iron 2 plus, copper 2 plus, the sign, right? So you write with this iron, react with copper 2 plus, that is copper here, 2 plus iron, to make, that means on the other side of the arrow, iron 2 plus, this one, and copper. Copper the metal. Copper the metal you write without iron. Now just it makes sense, right? Makes totally sense if you write like this. But when you write this kind of like nonsense, sometimes our people write nonsense like this and think that this is going to be right. What is this? What is this say? You just by heart something and go and write nonsense and think that is correct, and you call yourself a science student. Okay, that doesn't make sense. Makes sense. Okay, with reactions like there's meaning here. Okay. All right, let's take the next one. So this observation. Right, observations you can write. Those are the products. Those are the reactions they're asking. Right, what about next one? Where was this one? What was it? Now take on photos and the other one. It's also I just did. I'm taking from the ground first. Okay. They have given the Ionic equation here for this one. And copper sulfate. Copper 2 sulfate reacts with aqueous potassium iodide. Now this is good one. It's a good one. Let's see what it is. Aqueous copper sulfate. You know the substance, whatever you see the substance, you should be able to write the compound. Copper sulfate.